Hi, this is Sanya. So, for my final project, I will be analyzing the situation of traffic accidents in Boston, Massachusetts. In order to introduce the topic, I would like to point out that according to the National Security Council, traffic deaths in Massachusetts they have increased by 13% from 2015 to 2016. So, which is actually more than double of the national average of 6%. The number of people killed in road accidents was about 354 in 2015, and this number went up to about 400 in 2016. So the most common reason behind these motor vehicle accidents is driver's distraction due to cell phones or GPS tracking and alcohol consumption. Below average seatbelt use and congested road networks are also some of the factors that lead to increased number of fatalities in the city. So the problem in hand is that in the city of Boston, the number of casualties due to road accidents have increased, and therefore there is a need to understand the reasons behind increased number of road accidents in the city. The challenges involved are that there is no proper tool for modeling and analyzing the road accidents that occur in the city of Boston. The motivation behind this is that Boston is actually struggling to reduce the number of road accident and casualties that take place every year. There is a need to identify the areas where these road accidents occur the most so that necessary actions can be taken by the concerned authorities in order to reduce the number of accidents that takes place. If you see the two graphs, so the graph on the top, it actually shows that in 2017 about 3,361 cases of car accidents were reported, and in 2018 about 3,262 car accident cases were reported. Now this number is not very less as compared to the 2017 data. The graph at the bottom, now if you observe the graph for 2015 and 2016, so you see that the number of pedestrians who have been injured in fatal crashes, now it has actually gone up. So now the project objectives. So the first objective is to find the data for analyzing the road accidents in Boston. The second objective is to use ArcGIS to perform to identify the hotspots. Now hotspots are basically areas that have high rates of road accidents, that is the areas where road accidents occur most frequently. Another objective of this project is to perform a spatio-temporal analysis to analyze the road traffic fatality rates. The last objective is to create visual representations of the findings and the patterns in the form of bar graphs and thematic maps. So the significance of this project. Now, this research can actually be very helpful to the concerned authorities and policymakers in identifying the areas that need attention. By adopting necessary interventions for public safety, there can be a reduction in the fatalities, injuries, and traffic accident cases in Boston. On a bigger level, this approach can also be used by other cities who are also dealing with high road traffic accident rates. So for the literature review, so Yamazaki, he proposes a methodology for identifying the novel features related to the traffic incidences in Niigata Prefecture of Japan. Now for this analysis, he has considered two data sources. Now the first one is the open data that is actually owned by the government and the municipalities, and the second data is owned by the prefectural police department. Now the author performs the fundamental analysis using ArcGIS. Now he analyzes the accidents per month and per hour. So if you see the graph on the top, so it actually represents the road accidents per month. So if you see the V2V accidents, that is vehicle to vehicle accidents, now they usually occur, they are more common between the months of May and July, and the human to vehicle accidents, now these accidents, they are more common during the month of July, January and December. Now the reason behind this could be that this region of Japan is actually famous for high snowfall. So that is why there is an increased number of human to vehicle accidents in this region. Now if you see the second graph here, so this is actually analyzing the accidents on hourly basis. Now most of the vehicle to vehicle accidents, they usually occur during daytime, because that is the time when people are more active and they have their cars out than the night time when people are actually sleeping. So another striking aspect of this map is this graph is that, so for the human to vehicle accident, so there is a peak at around 5 p.m. So that is also a very peculiar feature of this graph. Now the author has also tried to analyze the accident data based on the presence of traffic lights. So this graph here actually shows the results of the analysis. Now the author has found that for vehicle to vehicle accidents, so there are more accidents in the intersections which do not have any traffic lights, and actually the difference between the accidents that take place in the intersections with traffic lights is actually very, very small as compared to those with no traffic lights. This is actually more than triple the height of the this bar graph. So that is also one of very important results of this analysis. Then the second literature here is by Anderson. Anderson, he proposes a methodology for identifying the hotspots in London, UK. The author has actually used GIS and the kernel density estimation to find the hotspots. Now, the results obtained from the above step have been combined with the environmental data. Now, environmental data basically includes information about the road length or the cycle lane length, the bus stops, schools, and traffic lights. Now, the author has used this data to actually perform k-means clustering, and at the end of the analysis, the author has been able to find 5 groups and 15 clusters. Now, these clusters have been represented on this graph on the right hand side. Now, if you see that for each cluster, the author has represented the number of hotspots that lie within that cluster. So you can see that for cluster 4, there were about 40 hotspots that lie in this cluster. So the methodology. So in this project, the first step would be the data collection. The data would be taken from the mass.gov website. It has a crash data, so I will be using that data. The second step would be to perform a hotspot analysis using kernel density estimation. Now basically kernel density estimation actually calculates the magnitude per unit area quantity from point observations using a kernel function. Now the third step would be to identify the temporal patterns by the use of bar graphs. Now we can actually use bar graphs to analyze the accidents on monthly and hourly basis. And the final step would be to perform a space-time pattern map, spatio-temporal analysis. So basically, the space-time pattern mapping mining tool will be used to explore the spatio-temporal hotspots based on the fatality rates of the incidences. So the expected results would be as follows: analysis and maps identifying the hotspots in Boston, Massachusetts, that is the areas which have high accident rates. Another result would be bar graphs analyzing different aspects of the nature and the characteristics of the road accident data. And the third expected result would be a map which would show the spatio-temporal analysis of the fatalities of road accident in the city of Boston. And thank you.